About scientific notation. First off, on your calculator, if you look at my calculator, you're probably going to have an EE button. So 5EE 3. So that would be, so 5EE 3 would equal 5,000. So that EE means that you're times 10 to the third. Other calculators have it other ways. Since I'm not there, I can't look at your calculator and tell you how to do it. So you want to make sure that you know how to enter these numbers into your calculator, or else you're going to get possibly very, very wrong answers. But let's just review scientific notation real quick, just to make sure everybody's on the same page. So scientific notation. It's the way we take really big and really small numbers and make them more user-friendly, I guess. So if we use Avogadro's number, times 10 to the 23rd atoms. What this really means is that we have 6, and then we move the decimal 23 spots to the right. So we had the decimal here, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that is 6.022 times 10 to the 23rd. As you can see, it's a very large number, and it's just easier to manage when you've got the exponent, the times 10 to the 23rd. Our scientific notation, a couple basic rules, should be numbers between 1 and 9, and then times 10 to some power. Now, positive exponents like this one here give big numbers, give bigger numbers. And negative exponents give smaller numbers. So let's say that we have 6.022 times 10 to the negative 23. Of something. So in this case, we're going to have the 6.022, but instead of moving to the right, we need our number to get much smaller. So we're going to move it to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And now our decimal point lives here, and we would put zeros in all those little hoops. So as we can see, this number that I just did is very, very tiny and way different than this number by like a magnitude of 46. So it is very important that we get the correct exponents and the correct number of moves for our scientific notation. So I'm going to give you a couple real life examples. Let's say that your yearly bonus at your job is 1.2 times 10 to the 5th US dollars. That's a good bonus. So what you're expecting is 1, and then let's move our decimal, 2. So this is our first move 1, 2, 3, 4, 5. Right? We moved our decimal from here 5 spots to the right to make it bigger. 1, 2, 3, 4, 5. Now that's 120,000 US dollars. That's a lot of money. But let's say that you don't know how to use scientific notation and your boss thinks he can pull a quick one on you, so he gives you 1.2 times 10 to the fourth. He just cuts you by 1 spot. So now we have, and we're only going to move it 4 spots. 2, 3, 4. So by moving that, or by changing our number in our exponent by 1 spot, we changed our number by 108,000 in this example. This is a difference of 108,000. If I had $108,000 right now, I could get all the way out of debt. That'd be nice. So that's a big difference. That's why the exponents in scientific notation are so important. Now let's look at one where we mess up the positive and the negative. So we get the same exponent, but we aren't sure if we made the number bigger or smaller. We can use the same first example. We got 1.2 times 10 to the fifth, which we know is 120,000. But what is 1.2 times 10 to the negative fifth? So we just accidentally put a negative sign in our answer. Well, we got 1.2, 1, 2, 3, 4, 5. So before, where we just had a change in 1 0, which is still a lot, now we have moved the decimal the completely wrong way. So basically, if you were getting paid here, instead of getting $120,000, you would get way less than a penny for your yearly bonus. And that is an extreme difference. And that is why scientific notation, it is important to make sure that you are using the right numbers and you are using the right signs on the exponent.